Hi, my name's Lucinda Whelan. My student number is S00188400, and I'm doing type 2 diabetes mellitus. So my client is Beth Simpson. She's female. She's 54 years old. She has type 2 diabetes mellitus. She's overweight. For exercise, she walks her dog around the block once a day, and she does gardening on the odd occasion. She's an accountant. She lives alone and is divorced, but she has kids nearby. Her mum had type 2 diabetes when she was alive. She's not pregnant. She used to be a smoker, and she does drink on special occasions. And the medication that has been prescribed for her is metformin.
Okay, so for the first question regarding to diabetes, I chose to talk about insulin binding to the target cell and insulin release. So in a healthy non-diabetic person with insulin binding to the target cell, insulin is a large peptide molecule, and in a healthy person, insulin binds to an insulin receptor on the target tissue, which could be fat, liver, or muscle. The receptor-bound insulin triggers certain GLUTs, and the GLUTs will pick up the glucose from the blood, causing a decrease in blood glucose levels. Whereas in a diabetic person, so a person with type 2 diabetes, there is not enough insulin being produced. Therefore, it cannot trigger the transporters or the GLUTs to pick up the glucose from the bloodstream and bring it to the tissue. And sometimes insulin is unable to activate GLUTs if insulin resistance is occurring. Okay, so for a healthy person, insulin release, is released from the pancreas, and it is triggered by an increase in blood glucose levels. Insulin secretion is a biphasic process, meaning it has two phases, and the first phase is rapid and really quick releasing, but the second phase is longer, and it takes longer to occur as more insulin has to be made before it can be used again. For a diabetic person a person with type 2 diabetes, there is insufficient secretion of insulin from the B cells of the pancreatic islets, causing impaired insulin action in the target tissue. So because of this, hyperglycemia can occur when insulin secretion is unable to compensate for insulin resistance. Okay, so for consequences of long-term hyperglycemia, I chose stroke and renal disease. And with stroke, if you have type 2 diabetes, the chances of having a stroke is going to increase anyway. But over time, high blood glucose levels can lead to increase in deposits of fatty material on the inside of blood vessel walls. This is called atherosclerosis, and atherosclerosis causes narrowing of vessels, which can lead to blood clots getting stuck and cutting off the oxygen supply to the brain, which can then turn or cause a stroke. I drew a picture. I don't know if it's going to work. So here is the blood vessel. The dark orange is the atherosclerosis, and here is the blood clot that is stopped. Blood caused a blockage, and so no more blood and oxygen can get up to the brain. So renal disease is also a long-term effect of hypoglycemia, and when our bodies digest the protein we eat, the process creates waste products. In the kidneys, there are millions of tiny blood vessels, which are also known as capillaries, and these capillaries have tiny holes which filter out the waste and allow the blood and protein and nutrients to continue through. So high levels of blood sugar make kidneys filter too much blood, and all the extra work is hard on the kidneys and the filters, and it puts pressure and stress. So after many years, they start to leak, and the useful proteins are lost throughout the filters. Eventually, the kidneys lose the ability to filter at all, which allows accumulation of waste in the blood. And that causes renal failure.
Okay, so the last question was, what drug do we use to help people with type 2 diabetes mellitus? And it is metformin. Metformin helps control blood sugar levels, and it does this by working to restore your body's proper response to insulin that you naturally produce. It also decreases the amount of sugar your liver releases and that your small intestines uptake, and metformin prevents things like stroke and kidney failure. I think that's it. Thank you very much for listening. I'm sorry if it was boring. Thank you.